All right. Hello, everyone. My name is Philip Conrad, and I'm one of the maintainers for the Open Policy Agent project. I'm presenting these slides on behalf of my colleague Sebastian, who couldn't make it to KubeCon this year due to a family emergency. So these are his slides, but my words. We'll be talking this year a little bit about OPA performance improvements, but if you don't know what OPA is, the Open Policy Agent is a CNCF graduated project. The project as a whole is about 10 years old and has been a CNCF graduated project for at least 4 years. Folks tend to describe it as a general purpose policy engine, but what's a policy engine? In the context of software, policy is sets of rules and conditions that determine the behavior of a piece of software. And an engine is something that takes an input and produces an output. When you combine these ideas, you get something that takes an input, runs it through rules and conditions, and produces an output, which is what OPA does. In the example on the slides behind me, you can see that we have a user named Alice who has the admin role, and we have a policy that checks to see, is this person an admin? And in this case, they are, and it produces true. Policies allow you to decouple a lot of your authorization logic from your applications and also allow checking for things like, in the context of Kubernetes, do all of these containers come from a trusted registry? This is a simple example, but much more complex ones are possible. Over the last year, we released a 1.0 version of the project. Up until literally the last year, the project was just 0. whatever. And so we finally locked in a bunch of language changes that have been made and made a ton of performance improvements over the last year, mostly from doing less work where we didn't need to be doing it, fewer allocations on a lot of the hot paths, and dramatically improving the efficiency of the AST-based interpreter. In version 1.0 in particular, we started using sync.pool much more heavily. If you're familiar with that from the Golang world, this allows you to reuse allocations you've already made and avoid thrashing the garbage collector. We also, in version 1.4, dramatically improved the efficiency of several of the text handling built-ins, so we make fewer allocations when we don't need to. And my colleague Sebastian, in version 1.3, contributed something that greatly improves the performance of generating decision logs, which are very handy if you need to have audit logging for your Open Policy Agent instances. We've continued this trend in the later part of the year with more improvements to the AST compiler, improving the storage layer, and improving OPA's rule indexer. The rule indexer allows OPA to decide early if it needs to bail out of evaluating a policy. OPA can sometimes tell when a rule will not succeed based on the input. And this recently got extended to handle a couple new classes of rules that it was not able to index before. If you haven't upgraded to the 1.0 version of the language, it is relatively easy to do, but we have a lot of tools that make that upgrade process easier. In some cases, many of the upgrades can be made automatically with OPA format. If you've never tried the Regal linter before, I strongly recommend it. It's also part of the open source project community and will help you write better Rego code. We have a bunch of really cool things also planned on the roadmap. Some of these things include convenience features like new keywords and string interpolation. We also have a bunch of improvements planned for the rule indexer, type checking, and more. And we would love if you got involved. The Slack community is very welcoming, and if you're interested in trying out OPA or having issues adopting it, please ask in the help channel. People are really helpful in there. We do have a booth here this year down at Kiosk 12A, and there will be a maintainer talk on Thursday. And we have a community survey coming up soon. All right, thank you everyone, and hope you enjoy the rest of your conference.